Good morning, my YouTube viewers. In this video, what we're going to talk about is simple linear regression. And the formula for simple linear regression is y equals a plus bx. So y is your dependent variable and x is your independent variable. So regression analysis is a predictive modeling technique that examines the relationship between a dependent variable response and one or more independent variables predictors. Unlike correlation, regression provides an explicit equation to describe the relationship, enabling predictions and interpretations. And so the thing about linear regression is if you studied machine learning, then you'll know that linear regression is a part of machine learning. But the thing is that you may not know is linear regression was a part of statistics before it was a part of machine learning, because machine learning is a newer science than statistics is. So what I've done, if you watched my last video, we did a study of hours studied versus exam score. And so your hours studied is X, which is your independent variable, and your exam score is Y, which is your dependent variable. And so the idea is the more you study, the higher your exam score is going to be. And so what we've done is we've got hours studied and the exam score, and we've made a chart based upon the hours studied and the exam score. And you can see that we've got the formula for the simple linear regression, and we've got R equals 1. And in our last video, R squared equals 1. And on our last video, R squared equals 1 as well. So in addition to creating a chart, what you can do is you can do a summary output, and which is what we have done here in this video. So what you do is you come over here to data and you go to data analysis. And then so what we want to do is you're going to do regression and click OK. And then your Y is your input range. So that's going to be B3 to B13. And your X range, or we're going to say B2. And then your X range is going to be A2 to A13. And then so basically we're going to set it up labels. So that means the first row is going to be labels. You're going to set it up, and then you're going to say, you can set it, I set mine up for an output range. And then when you set it up for the output range, you set it up for A17. We would say A17. And then what you would do is you can calculate residuals, standardized residuals, residual plots, and line fit plots. And you would also have normal probability. But I've already done that. So you would click OK, but because I've already done that, I'm just going to click cancel since I've already done that. So this is your summary output for your regression statistics. Multiple R is 1. R squared is 1. Adjusted R squared is 1. Standard error is really low, 3.99 to the negative 15th. Observations is 11. And so now it's going to do an ANOVA, which is an analysis of variance. So you do your regression, your degree of freedom is 1, your sum of squares is 2750, your MS is 2750, your F statistic is 1.72 to the 32nd, and your significance F is 4.393. You check your residuals, and then you check your total, being the degree of freedom is 10, and your sum of squares is 2750. And then we check our intercept and your hours studied. Your intercept is 45. Standard error is really low. T statistics really low. P value is really low. And your lower 95% is 45, your upper 95% is 45. Again, your lower 95%, 45, your upper 95%, 45. And then we go with hours studied. So the coefficient is 5. You've got a really low standard error, a really low t-statistic, a really low p-value. And then so your lower 95% is 5 and your upper 95% is 5. So there you go. You can make yourself a chart so you can see what the simple linear regression is, and you can also do a summary output of the linear regression. So the next video is going to be on multiple linear regression, so I hope that you decide to watch it.